Hi, Liam. Let's quickly look at this sum. Give with reason three more angles which are equal to x. Now, in this example, they gave you a1 equaling x. Okay. So the other angle that is equal to x is d1. So you can write that d1 equal x, and that's alternating angles because AB is parallel to ED. Then there is also d1 that equals x, and that is tangent chord statement. So there's my tangent and there's the chord, and those two angles are the same. Then a third angle, I think this one's quite difficult to see. Equal chords have equal angles. So this chord and this chord is the same. So AE, it's got x there on the segment of the circle, and AB will have x there. So those are the three angles. I'm not going to write it down. You can write the reasons for yourself. Okay, so that's done. That's three other angles. Prove that DEA equals DBC. So it's always nice to go and highlight the triangles. The one is DEA. It's this one here, yellow one, blue one, and then DBC be this yellow one. So basically you need two angles that are exactly the same. So you're going to write in triangle DEA and DBC, we have one. Well, D1 equals D3. D1 equals D3 equals X, and that's proven. What else? You need one more angle. Okay, B2 equals E. Why is that? That is exterior angles of a cyclic quad. So those two angles are the same. And therefore the third angle, which is A2, must equal C. And that's angles of a triangle, or interior angles of a triangle. And therefore triangle DEA is similar to triangle DBC, and the reason is angle, angle, angle. Okay, so now you've got those two triangles the same with your reason. Okay, let's make that small, put it there. Okay, now from that I can do the following. I can draw that triangle DEA and draw a similar one inside it. The same angle E and B is the same, so I can align E there, and then in the small triangle D1 is the same as D, so I've got D there. I think so. And then C and A the same. So now out of that you can write that DC on top of AD equals BC on top of AE, and that triangle DEA being similar to triangle DBC is the reason. So I just went inside over outside is inside over outside, and now you can multiply right through with AD. So DC equals BC times AD over AE. Okay, but I don't need that. I want AE to be replaced by DB. Okay, so we need to find a reason why AB and DB are the same. So why is AE and DB the same? Well, look at the angles that they support. They both support angles X. So you can give that reason. So AE equals DB, and that is similar chords, similar angles. So now I can just replace AE with DB. So therefore DC equals BC times AD over DB. And that's finished then. Okay, I'm just going to leave it like that for 10 seconds so that you can actually look at it. Write it down maybe, or screenshot it. Okay, I'm going to make that small. So the next question is what? I deleted the side now on that triangle. I think it was D here. So they want to know, I can prove the following. EA is DC times DE over AD. Now out of that triangle, you can have the following again. You can have DC on top of AD, that's inside over outside, equals BD, now we're using this one, on top of ED. Okay, so now I multiply again with AD. Now, let's keep BD, because DC, okay, I'm going to multiply right through with ED. Then BD equals DC times ED over AD. That's the same as this one, DC times DE over AD. But now I don't have AE here, or EA, I have BD. So I have to prove that BD is the same as EA. Okay, let's look at our drawing. Well, we just did that. Those must be the same because they support the same angle. So BD equals EA, and that's proven. So therefore EA equals DC, and then instead of ED I can write DE, it's the same thing, over AD. So that's done. Again, take our 30 seconds, write it down or screenshot it. Okay, I'm going to make it smaller again. Let's just make some space here. Okay, next question. You must prove that AE square equals BC times ED. It's 2 marks. It's really easy. What I'm going to do, I've got AE already, or EA. So I'm just going to say AE times AE is AE square. And I've got one AE there. What is AE? Well, according to that, I've just done AE is DC times DE over AD. And then I'm going to multiply it with another AE. Now in the previous sum, we had the following. We had, I think, let's just make that bigger. I think this is the first one. No, it's not the first one. The first one is now hidden. In the first one, we proved the following. I can't find it now. In the first one, you proved the following. DC equals BC times AD over DB. Okay, so we've proven that somewhere. Okay, there it is. Okay, so I can make AD the subjective equation. I multiply with DB right through. So DC times DB, and then I divide BC. and then I have AD. So I can just plug that in out of my first, the first thing I've proven, 331. So instead of A, because I have an AD. Well, this is wrong. This is wrong. I don't want to make AD the subjective equation. I don't want to make AD the subjective equation. I want AE the subjective equation. I don't have an AE there. What is the same as AE? Well, I can... AD is not the same as AE, but BD is the same. So I should have made DB the subject of the equation. So let's just fix that. Okay, so I can have DB, subject of the equation. So DC times DB equals BC times AD. So DB equals BC times AD on top of DC. And then I plug that in because DB is the same as AE. It's proven. So now instead of a DB, I can write BC times AD on top of DC. So those two cancel, that one and that one cancels, and then I have DE times BC, and then it's proven. Okay, hope you get right.